So yesterday we ended with this note right here, and the answer that you should have is potassium nitride. If you got that, you are correct. And if you did not, then you could take a look at which one is the metal and non-metal, and remember the rules in naming these elements. All right, so that's a combination reaction. Now, we're going to cover a new one today, and that is called a single replacement reaction. So a single replacement reaction happens when you're combining more than just two elements. So now you're combining an element and a molecule. All right, so I will start with just listing down a couple, like a formula, an example here. So let's start with an example. Let's say that you are going to combine something like lithium and you are going to add something like sodium chloride. So if these elements do react, and some of these we're just using more as an example, so they might not actually combine in real life, but in theory, they probably would combine. And so what would happen if they did? So now the first thing that you'll have to keep in mind is identifying which one the metal and the non-metals are. So for example, you know that lithium here is a metal, and we know that sodium is also a metal, but chlorine is a non-metal. And so what happens in this scenario is both of these will switch places. So the two metals will switch places, and therefore you should get something instead like sodium and lithium chloride. So you could see how there was the switch, and the switch caused these new elements to be formed. So to make this a little bit easier to understand, we're also going to use a little formula here, kind of like what we did last time. But now we're going to have three elements. We're going to have the letters A, B, and C. I'm going to use the color orange to represent something like a metal, let's say. So A, and then it's going to combine with elements B and C. And so you could see that the green there represents the non-metal. And so you should get the element B instead on its own there, plus, and then you should have A and C. I'm going to write one more example down in case you want to see an example of what would happen if the non-metal is the one that switches. So let's say let's start with element D, and let's say it combines with element E and F. And then you should get the element F here instead, right? Because the D and the F are the ones that switch. And then the other element will then be E and D. So these are two kind of examples there that you could use, hopefully. So when one of them is a non-metal or another one is a non-metal, you know, a metal or a non-metal, then you'll know that the ones that are alike are the ones that switch. So this is an example of a single replacement reaction. And we're going to put a box around this one as well, just so we can keep this in mind. All right. So remember that before this age, like people didn't know how new elements formed. And now we know how these molecules can change around with these rules. We can make predictions of what would happen. So one more thing that I would like to introduce here are the hydro families. So this relates with double replacement, so don't forget this just yet. But let's talk about hydro, I'm going to call these hydro elements. And in parentheses, we're going to write acids because these are actually acids, something acidic. And you're going to actually see one familiar example in a second here. All right. So one of these hydro elements that we might be aware of is something like hydrochloric. Or actually, you know what? Let me start with this. These are elements. These are molecules with hydrogen. Okay, so that's what hydro elements are. And so, for example, one that we might see here is hydrochloric acid. So now, what is hydrochloric acid? Well, that's our simple way of saying this is a combination of hydrogen and chlorine. So you could see that the hydro from the hydrogen, the hydrochloric, right, that's taken from the hydrogen, and then the chloric is taken from the chlorine. That's how we get the naming. So that's one example of an element that we have here. Now, what happens when we have a single replacement with something like hydrochloric acid? So take a look at how the name here might look a little bit different, but it's really the same concept. So let's say that we have something like iron. And let's say we're mixing some iron with hydrochloric acid. So what would this turn into? Well, it's important to keep in mind that the acid is not actually its own element, okay? So we could actually ignore acid for a bit here. In fact, moving forward, we're not going to write the word acid again because it's not going to be hydrochloric acid. So you have to identify, first of all, what is the iron? Is it metal or non-metal? And based on our example here, or if you look at the periodic table, I mean, you're going to notice that it is a metal. So I'm going to put the letter M there just to kind of give me a better understanding of it. And then hydrochloric acid. So what is it made of? Well, we just discussed that it is made up of hydrogen. And hydrogen, I'm going to write down the letter M underneath it to identify that it is also a metal. And then chlorine is a non-metal. So now think about the two that switch. The two that switch are the iron and the hydrogen. So what are you going to be left with? Well, on this side, you're going to start with hydrogen. And then on the other side, now you have iron and chlorine. So how do we write this down? Well, we should write it down as the metal first, which is iron. And the second one is chlorine, but we can't write just chlorine. Remember, it's a non-metal. So now we have to go back to the rules that we just learned, and it should be iron chloride. So if you mix iron and hydrochloric acid, what does it become? Well, it becomes hydrogen and iron chloride. Another element that is similar to this, or another molecule that is similar to this, is what we call hydrobromic acid. So let me write this down first. Hydrobromic acid. All right, so what is hydrobromic acid? Well, let's look at the words again. We got hydro, and we have bromic on the other hand. And so from the hydro, hopefully you could already predict that this is also hydrogen. And now the bromic sounds a lot like bromine, and that's exactly what it is. So it's a combination of hydrogen and bromine. Okay, that's what hydrobromic acid is. So let's take a look at another example here. So what if I were to combine something like, let's say, an example, let's have iron again. And this time I'm going to mix it with the hydrobromic acid. Oops, and then you could pause this for a second to see if you could figure this out on your own as well. And then when you're done, you could click play again. So if you want to pause, you could pause right now. All right, and if you're unpausing, then you should be left with, all right, what do we have? Well, we have the hydrogen again. And you have the iron combining with the bromine, which makes this bromide. All right, so a couple more examples that I would like you to try out just for practice purposes. The first example here is, what do you think would happen if we were to combine magnesium with hydrochloric acid? And what would happen if we were to combine zinc along with hydrobromic acid? All right, you could go ahead and try to complete this and see what you come up with, and we'll continue on with our lesson later.